Welcome to this explainer. Today, we're diving into a truly mind-blowing case study from 2016. It's one that perfectly captures the sheer exponential power of modern computer science. You know, we throw around buzzwords like scaling and impact all the time, right? But it's pretty rare to get a stark, undeniable contrast between old-school physical infrastructure and agile software engineering. We're going to look at how a tiny group of people literally outperformed the entire world, and how mastering technical fundamentals completely rewrites the rules of global influence. Let's get right into it.
Section 1. The 2016 Messaging Milestone. Setting the stage with the Goliath of communication.
To really grasp the magnitude of what happened in 2016, we've got to take a look at the sprawling legacy infrastructure of the time, which naturally brings up a pretty interesting question. How many engineers does it actually take to outpace the world? Seriously, if you had to guess the amount of human capital needed to beat a deeply entrenched worldwide telecommunications system, what would you say? You'd probably picture massive skyscrapers packed with thousands of developers, wouldn't you?
Well, let's set our baseline. 20 billion. Back in 2016, the massive Goliath that was the global SMS system was churning out an incredible 20 billion messages every single day. Just pause and think about the physical reality of that number for a second. That was the combined output of practically every telecom giant across the globe. It relied on decades, literally decades of established infrastructure. We're talking undersea cables, thousands of cell towers, massive server farms, and enormous workforces working around the clock just to keep the lights on. It was this monolithic achievement of the 20th century. 20 billion daily messages was the absolute gold standard of global reach.
Section 2. Legend of the 57. The Unexpected Challengers. But here is where the plot twists. While that entire global SMS network was handling those 20 billion daily messages, a completely independent platform called WhatsApp handled 42 billion. No, that is not a typo. 42 billion daily messages. They more than doubled the global standard. Decades of heavy, expensive SMS infrastructure was suddenly dwarfed by an agile challenger operating completely under the radar. It just completely shattered the conventional wisdom that you needed physical infrastructure spanning across continents to process communications at that kind of scale.
And the real shock value here? That 42 billion message volume didn't come from a massive factory or some huge coalition of multinational corporations. It came from a small office of just 57 engineers. Just 57 people. It's honestly the ultimate David versus Goliath story of the modern digital era. It perfectly demonstrates the wildly disproportionate impact a tiny, agile engineering team can have. I mean, think about it. 57 people were effectively outperforming the combined technological output of the entire global telecommunications industry. Absolutely wild.
Section 3. Power of Digital Leverage. The mechanics behind the milestone.
Okay, so how did they actually pull this off? It wasn't magic, and it definitely wasn't a fluke. It all comes down to a concept called the digital leverage of scale. Basically, this is the ability to use modern computer science fundamentals to amplify a tiny team's output so drastically that it achieves a massive global impact. Instead of trying to scale up by hiring more humans or building more physical machinery, you scale through the pure, frictionless mathematics of software.
And to achieve that specific kind of leverage, you really need three key catalysts. First, a ruthless focus on scalability. Second, extreme system efficiency. And third, deeply advanced engineering skills. This small collective didn't win by just throwing more bodies at the problem or, building more cell towers. They won by writing better, more efficient code. Code that could scale infinitely without snapping under the weight of billions of users. By optimizing their back-end architecture, they could handle hundreds of thousands of concurrent connections on a single server, drastically reducing their overhead. So it wasn't about outspending the legacy systems at all. It was about out-engineering them, finding the absolute most efficient pathway for a piece of data to travel from point A to point B.
Section 4. Building for Billions. The True Power of Modern Computer Science.
The ultimate lesson here is how this reality has fundamentally reshaped our world. Digital expertise enables global influence entirely without the need for a massive workforce. Advanced engineering skills let you bypass those old traditional physical limitations completely. Because of the leverage you get from a deep understanding of computer science, the barriers to entry for changing the world have totally shifted. You don't need physical capital to have a global impact anymore. You just need intellectual capital. If you can write the code, you can deploy it to the world in an instant.
To sum it all up, the mastery of technical fundamentals enables a tiny collective to outperform massive legacy systems. It's not just about knowing a coding language or cobbling together a basic app. It's about an absolute, rigorous mastery of those core fundamentals. That is what allows a group of just 57 people to sit in a single room and build something that effortlessly handles over 40 billion interactions every single day. It's a profound testament to what's possible when deep technical knowledge meets pure, undistracted execution.
So, armed with this understanding of digital leverage, the limits of what a small, dedicated team can achieve are practically non-existent. Knowing the sheer, incredible power of engineering mastery that we've explored today, what tools could you potentially build to impact billions?